All right, let's get sampling, proportioning, distribution. I don't know. Let's do it. Information on a packet of seeds claims that the germination rate is 92%. There's approximately 160 seeds in each packet. So, what conditions do we need to use a sampling distribution for the proportion of seeds that are going to germinate? Again, we know that on average, each seed should have a 92% chance of germinating. So we're curious about if we plant a bunch of packets, what proportion in each packet do we think is going to germinate? We should expect 92%. How much will they be spread out? What are the chances of different germination rates? Assume the company selling these seeds has thousands of these packets and each seed is randomly put into the packet. So if you remember, the three conditions were independence, randomization, and sample size. So independence, randomization, and sample size. Well, independence, well, we're only looking at 160. That's our sample size. Germination rate is our population proportion, is what we're assuming. So is our sample less than 10% of the population? Well, if the company has thousands of these packets, then yes. We can assume independence. Our sample is less than 10% of the population. How about randomization? Well, we're assuming each seed is randomly, yep. Sample size? We should expect 10 successes and 10 failures. How many successes would we expect? Also, I forgot to mention this, but I would highly recommend you actually pause the video and see how much of this you can get done on your own, and then we can watch it together and then see how you do, or get you unstuck if you're unstuck, and then you could unpause it and pause it and just keep working is maybe the best way to practice. But if you just want to watch it along with me, that's fine too. So this is how we can find out. This is just P times N. This is how we can find out the expected number of successes. Let's type that into a calculator, 92% of 160. And we're going to get 147.2. Yep, that's at least 10. So the success part is good. The failure part, though, is going to be a little smaller. What's left over, or we could actually just type it into our calculator, 0.08. 12.8 failures. Yep, that's more than 10. It's kind of close, but it's more than 10. So yes, right? 147.2 and 12.8. These are both at least 10. So we have all three conditions we need for sampling distributions. So this tells us that p hat is normally distributed. Woohoo! So now we need to find its parameters, its mean and standard deviation. P hat, normally distributed. What's the mean of a sampling distribution of proportions? The mean of a sampling distribution for proportions is just the population proportion. That's what goes in the first blank. What's our population proportion? 92%. The standard deviation for a sampling distribution, what goes in the second blank, is just the square root of PQ over N. What's the square root of PQ over N? We'll have to find that out. 0.92 times 0.08, all over our sample size of 160. We'll type that into a calculator. 0.92. We can use parentheses if we want it to look nice. Make sure the square root covers everything. And we're going to get 0.021448. Five significant figures is a good rule of thumb, but make sure to always follow the instructions. We can see that the digits that we have after the first few zeros, there are 5 of them here. All right, so there we go. That's our sampling distribution. We should expect 92% to germinate. On average, how is it going to change? Maybe plus or minus 2%. Okay, so between 90 and 94% of seeds germinating, we'd be 68% sure that should happen because of the empirical rule. Now we can draw this. Well, I can try. Draw a normal distribution. The average should be about 92%. One standard deviation above the mean is going to be 94%. Two standard deviations going to be 96%. Three standard deviations would be 98%. It'd be really rare for that many seeds to germinate. One below is going to be about 90%. Two below is going to be about 88%. And three below is going to be about 86%. Going to be really, really rare for this few seeds to germinate. This is where 68% of the data should lie. This is where 95% of the data should lie. Empirical rule. We have a normal distribution. What's the probability that more than 95% of seeds will germinate? What do you think? That's this area. Is this a big area or a small area? That's a small area. We shouldn't think it's very likely. But we should expect something not very likely. That's one of the best things that you can do when you're doing math like this, is before you even plug anything into a calculator, come up with some idea for how big of a number you should be expecting. And sometimes you'll be wrong and the answer will be right, but it's always good to get an idea, to go into it with a gut. So the probability that the proportion of seeds that germinate is more than 95%, this is a normal random variable. We find probabilities of normal random variables using GeoGebra. There are other ways of doing it, but that's how we do it. 92% is our expectation, 0.02 something, 02 1448. And again, this picture should look like the picture that we drew. 92 is in the middle. 98's 3 standard deviation. It's pretty rare. Yeah, 98 is pretty rare. So what's the probability that we're at least 95? We'll put 0.95 up here. Visually, yeah, you can see it's not a big probability. About 8%. 0.0809. Not very likely that this many seeds would germinate, but possible. Would it be unusual for 140 or fewer of the seeds to germinate? Well, okay, so we need to see or fewer. So we'll go over here, right, and do or fewer. Type in, wait a minute. We can't type in 146 because these are all proportions. Sorry, 140, because these are all proportions. We should be typing in a proportion. So what proportion is this? 140 over 160 is a proportion. We have to find out what that is. All right. 140 over 160, that's 87.5%. Well, we don't even need a computer to answer that. 87.5% or fewer? That would be unusual, right? That's a pretty small area. But let's use a computer to get a nice number. The probability that our sample proportion would be less than or equal to 0.875 should be some small number. Let's find out what it is. Yeah, it is. That's like 2%. 0.0179. Yes, it'd be unusual. There's only a 1.79% chance this would happen. So it's possible, but unlikely. And again, in Unit 8, we're going to look at this and say, so if this did happen, if we actually did plant a packet of these seeds and only had 140 germinate, either we got really unlucky, 2%, really unlucky, or this company is fibbing with their claim on germination rates. Or maybe we don't know how to plant seeds. Maybe we didn't follow instructions, but something probably happened. All right. And that's something that we're going to talk about in Unit 8. Anyway, let me know if you have any questions. This stuff is hard, so feel free to send tons of questions my way. You can do it, though. I believe in you. And good luck. Bye-bye.